Hi, my math friends. This is Mrs. Schlecht. And in this video, we're going to go over how you can represent polygons on a coordinate plane. All right, my friends, so before we get going on all the super cool math stuff, you know that there's a few materials you need in order to be successful for this activity. First, you're going to need your Envision textbook. That's the one with that little robot on the front. Second, you're going to need your math notebook to take those beautiful notes. Third, you're going to need a pencil. And fourth, last but never, ever, ever least, that positive math attitude. So also just a little hint, my friends. If you have graph paper or grid paper, you know, the paper with like the little boxes and stuff in it, that could be very useful and such a great tool for this lesson. If you have it, awesome. If not, super okay. Don't worry about it. Just make sure you're following along in your textbook and your notebook. Okay, friends, so this lesson goes over 2-6, which is in your Envision book. And again, we're representing polygons on a coordinate plane. Now, a polygon is any closed shape, but with straight sides. So a circle, I love a circle, but not a polygon because it just has that curved edges, right? No edges at all, Mrs. Schlecht, no sides at all, right? A circle is just a circle, so that's not a polygon. But we're talking about trapezoids, we're talking about squares, we're talking about rectangles, we're talking about rhombi, we're talking about all those hexagons, pentagons, octagons, nonagons. Anything with a straight side that's completely closed, that's a polygon. So we will be graphing all sorts of different cool kind of shapes on our coordinate plane, which is super duper cool, my friends. But you know that there's a couple of great pages that Mrs. Schlecht always loves to make sure that you are aware of. The key concepts page for lesson 2-6 is on page 108. We're also going to look at some of those practice problems on page 108 under the Do You Know How section. And the first one that we're going to do is number 4. Again, my friends, we are on page 108, and this is number 4. So a couple of different pieces of information I want you to be aware of before we actually start knocking this out, right? First, it's going to ask you for the entire perimeter of this shape. Now, you know, a perimeter is the distance around. We can think about the fencing in your backyard. It doesn't cover the grass, right? It doesn't cover the inside of your yard. We are just going to talk about the distance around it, all right? So perimeter, we'll find that, but let's just kind of tuck that in the back of our head for a second, okay? Second, you'll notice that the shape is called rectangle MNOP. What we do then, friends, is M, N, O, and P all have different ordered pairs that will show me where the corners of this rectangle are, all right? So in your book, it says rectangle MNOP, and what's that referring to? It's referring to the shape that we are about ready to create. How do you create a shape, you ask? Great question. Well, I'm going to plot these 4 individual ordered pairs. So we have M at -2, +5, N at -2, -4, O at +3, -4, and then P is at +3, +5. So what I'm going to do first, friends, is I'm going to plot all of these ordered pairs, and then I'm just going to connect the dots. All right, my friends, before I actually connect the dots in order to make our rectangle, I just wanted to point out where we plotted these 4 different points, right? So M is right up here. This is in our second quadrant. N is down here in our third quadrant. O is over here in the fourth quadrant. And last but not least, P is right down here, or right up there in the first quadrant. So now that I have plotted all 4 of my ordered pairs, these are the corners of my rectangle. Now I'm just going to connect the dots. Ta-da! See, I took the 4 ordered pairs. Those became our 4 corners, or the 4 points of our rectangle. And then I just connected the dots, my friends. But are we finished?
Nope.
No, of course we're not finished, my friends. Remember, it asks us to find the perimeter. Now remember, the perimeter is the distance around the shape. It's not the inside of the shape, it's the distance around. So if you recall, last week we looked at lesson 2-5. And what that did, my friends, is it helped us find the distance between 2 points that lay on the same vertical or horizontal line. And we're going to use some of that knowledge, my friends, in this week's lesson, all right? So this is what I want to do. What I want to do is I want to find, well, what is the distance between point M, which is up here, and point N, which is right down here? And then, what is the distance between point N and point O? And then, what's the difference between O and point P? And last but not least, what's the distance between point P and point M? And once I have those numbers, my friends, then I'm just going to add them up, and that will give me my perimeter. All right, let's think about absolute value, my friends. I have -2, 5, -2, -4. So if I add the absolute values of 5 and -4, I get 9. And what that means, my friends, is that there is 9 units between point M and point N. Now let's look at the distance between point N and point O. So if we notice, our ordered pairs have the same y value. And if you notice, they're still on that same y-axis right there, correct? But our x is a little bit different. So what's the absolute value, my friends, of -2 plus the absolute value of 3? That's 5. All right, here's one more thing I just want you to notice. Do you remember one of the qualifications in order to be a rectangle? What it means is that 2 sides are equal, and then 2 sides are also equal. So let's just pause really quick, my friends. If I know that this side is going to be a distance of 9, isn't that equivalent to this side of the rectangle that's also going to be 9? And if the bottom of my rectangle is 5, doesn't that mean that it's also equivalent to the top of my rectangle, which would also be 5 units? Yeah, you're right, my friends. Remember, a rectangle is a quadrilateral or a polygon with 4 sides. All of those sides are at right angles, all right? But remember, 2 are parallel and congruent, and then the other 2 are parallel and congruent. So, my friends, I was able to use that math practice about taking the knowledge that I know and applying it to a new fun fact by doing this, right? I didn't have to find the distance of every single side of that rectangle. I know that with my rectangle rules, if I find out the length and the width, I'm good to go. All right, but what's the perimeter then? Great question. So what we're going to do is we're going to add up all 4 of these sides, my friends, and then that would give us the perimeter of our rectangle. So we're going to do 9 plus 5 plus 9 plus 5. So my friends, after counting up the distance, the perimeter, we found that the perimeter of rectangle MNOP is 28 units. We say units because I don't know if this is feet, I don't know if this is yards, I don't know if it's miles, I don't know if it's like millimeters. So that's why we're just calling it units. Remember, this problem asked us to find the perimeter. Is it possible to find the area using a coordinate grid? Yeah, it's totally possible to also use the coordinate grid to graph a polygon and then find the area. So let's look still on page 108, but this time let's look at number 6. All right, page 108, number 6. This time we're graphing a square, not a rectangle. What's the biggest difference between a square and a rectangle? Do you remember? Well, remember, while they both have 4 sides and both a square and a rectangle are considered quadrilaterals because they're a polygon with 4 sides, a square has 4 equal sides all around. So while the rectangle that we made had 2 long sides, 2 short sides, remember the square, my friend, it's going to be equal distance all the way around that square. Keep that in mind because that might make helping find the area a little bit easier. All right, so the first step I need to do is make this square. So I'm going to plot these 4 points. We have A, which is at -4.5, +4. B, which is at +3.5, +4. C, which is at +3.5, -4. And then finally point D, which is at -4.5 and -4. So again, my friends, I'm just going to plot those 4 points. All right, my friends, before we actually connect the dots, let's just go over where these 4 points should be. So A is over here in the second quadrant, and that's because I have that -x and that +y. Point B is over here in the first quadrant because I have a +3.5 and a +4. Point C is right here, kind of where Mrs. Schlecht wrote her O for that last problem. Oops, but it's right here. The reason it's in the fourth quadrant is because it has a +x, but then that -y. And then finally, my friends, point D is over here in the third quadrant because it has not only that negative x, but also that negative y. So my friends, now that we have plotted these 4 points, the 4 corners of our square, next we're just going to connect the dots. So what I did was I wrote those 4 points and now I connected the dots. So as you can see, this big green square right here, I know it kind of overlaps our rectangles from problem number 4, but I know you're smart, beautiful people. I know that that's not going to trick you up, right? So we're looking at this big square right here. But remember, it asks us to find the area. So while perimeter, which is the distance around that rectangle, area is going to get us inside this square. And I want to know, well, how much room is inside that square? But let's think. Remember, we know that a square has all equal sides. So this side is the same as this side, is the same as this side, is the same as this side, correct? So all I really need to do, my friends, is find the distance of one side or find the length of one side of my square. And that's all I need to do. And then I'd be able to multiply that by itself in order to get our area. This is what I mean. So keeping that idea in mind about the idea that a square just has 4 equal congruent sides, what I did, my friends, is I just found the distance between these first 2 points, point A and point B. And I said to myself, I said, self, don't you remember that we can just add the absolute value and that would give us the distance? Myself said, yeah, I remember that. So what's the absolute value of negative 4.5? Well, that's 4.5, plus the absolute value of 3.5, which is just 3.5. And I knew that 4.5 plus 3.5 gave me 8. And what that means, my friends, is that the distance between this point A and point B, is 8 units. The distance between point B and point C is also 8 units. The distance between point C and point B, or point D, you're right, 8 units. And the distance between point D and point A, also 8 units. Now, how do we find the area? Well, we multiply, right? While perimeter is plussing or addition, that's how I remember it. The P for perimeter is the P for plussing. Area, we're going to multiply, right? Because I want to know what's all this business in here, right? How much room is in there? So I'm going to multiply the length times width. And it's so super cool in a square because that's the same number. So if the distance between each side is 8, what's 8 times 8? All right, so for the area, we just needed to multiply 8 times 8 because that was our length times our width, you know, area formula. And what we got was 64 units squared. Notice that I put that little 2, that little exponent 2 above our units. That's because this is square units because we're finding the area, right? Perimeter didn't need that square units because it's not square units. Just remember, area does. What we did in problem number 4 and problem number 6, my friends, is we found the area and the perimeter of different shapes that we were able to plot on that coordinate grid. If you have any questions about how we found the perimeter or the area, please just let me know. But there's one more that I really want to take a peek at with you. And it's actually on page 109, and it's number 9. This is page 109, number 9. And what this problem is asking us, my friends, is it gives us the 3 points of a triangle this time. So still a polygon, not a quadrilateral though, right? Because quadrilaterals got to have those 4 sides. This is still just a polygon, a beautiful polygon, a triangle. Let me tell you, my friends, triangles have so many cool different properties. We don't got time for that right now, but triangles, super duper cool. Anyway. So I have 3 points for that triangle, right? And what it's actually asking me, my friends, is this going to be an equilateral triangle? What that means is if I plot these 3 points and I connect my lines and everything, is that triangle going to be completely equal all the way around? Now, some of you might be able to just kind of look at these points and maybe you're kind of working some stuff out in your brain, but Mrs. Schlecht needs to actually see it. So I'm going to plot these 3 points and then I'm going to make my triangle. Before I connect the dots, let's just see where these 3 points needed to land. So first, J is at 0, 0. That point actually has a special name. It's called the point of origin. That's because it's in the center, right? 0, 0. J didn't really go in the building, didn't take the elevator anywhere, right? J is just at the point of origin, maybe like the parking lot or something, right? Okay, K is over here. So this has a X value of 5. That's why I came all the way over here. But notice I'm not riding an elevator anywhere. There's no more Y information. And then finally, my friends, point L, it's still on 0 for my x-axis, but then I went down to -3 for my y. So now that I have these 3 points plotted, my friends, I'm going to connect the dots. Friends, so I drew my triangle and now I connected the dots. So point J to K to L to J again, right? I know my drawing might be a little bit tricky to see because we got a rectangle, we got a square, now we got a triangle. I know, but just stick with me, okay? So kind of just focusing on this triangle. Notice that I have a right angle right here. Here's a little factoid, my friends, okay? If you have a right angle inside your triangle, there's no way that it can be an equilateral triangle, okay? Just the way that the angles will then be matching up and measuring up, there's no way that you can get an equilateral triangle with a 90-degree angle. So right there, I already know that this is not an equilateral triangle. But my friends, we can also find the distance. What's the distance between point L and point J? What's the distance between J and K? If those are not exactly the same, and they're not the same as the distance between L and K, then my friends, it's not an equilateral triangle. So for question number 9, it asks you to justify that answer. Well, there you go. 1, look at it. Look at this triangle. It is not an equilateral triangle. But also, we can also talk about the angle. It has a right angle, therefore automatically disqualified. But then also the distance between point L and point J and point K, those are not equal distances either. Therefore, it disqualifies that whole triangle as being equilateral. All right, my friends, so that was just a quick run through on lesson 2-6, how we can represent polygons on that coordinate plane. If you have any other questions, please let me know.